Hi. So hello,
Hello.
welcome. I am adding our Zoom meetings a bit last minute. So because of that, it might always start a bit later. And I do this with the hopes that we won't get Zoom bombed again. So maybe from now on we'll just start at 10:10. And then our Zoom meetings will not have like our class, like Math085, 10 a.m. I think I'll just put 10:10 for our meetings and give a date. And I hope that helps. But at any moment, if there is someone who's being disruptive or being rude on the chat, just feel free to just speak out their name and I can boot them out. I'm sorry about what happened last time. All right. So you ready to begin? All right, let's go ahead and get started. So I'm going to share my screen. And again, this is recording for those of us who can't be live with us. So everything's recording and I'll post the link as soon as it becomes available. Sometimes it takes like half an hour, other times it takes a couple of hours, but as soon as I get the email, I'll post it up, so don't worry. All right, so we're reaching the end of our review portion of the presets. So after this, we can kind of start dipping our toes into some statistics content. So this is section 4.1, and it's getting us ready for chapter 4 of your stats class that you'll have in hopefully either the summer or the fall. But let's go ahead and go over or going for this section. So this is section 4.1. To recall, we have worked with the number line. So recall, we have worked with the number line. And we know we can label numbers on the number line according to what we're being asked, right? Where to the right of 0, we have our positives, and to the left of 0, we have our negatives. And we can plot points, label where they are, see where they're greater than or less than. And we know that if it's greater than or equal to or less than or equal to, if it has an equal to, then it includes the number. It includes the number. If it has something like without an equal to, so greater than or less than, it's just a starting point. So the number is a starting point. For a quick little example, if I have x is less than 1 and I draw it on the number line, it's going to be less than 1, so we shade towards the negative, and we use an open circle to show that 1 is not included. So we want numbers like 0, -1, -2. Those numbers are less than 1. All right, now we need to be able to tie in the inequality with the written English phrase, the verbal phrase. If we can easily identify what it's referring to, and we can become strong at this now, when you move on to your next class, you'll save a big hurdle. So make sure these notes, right now, they're gold. Make sure you save them for next semester. All right, so this section summarizes all of our knowledge of the number line and inequalities. So first we have x is less than a. So the English phrase would be less than, smaller than. 2, we have x is greater than a. So numbers are larger than whatever number it may happen to be. So a is just a default number we're working with. Now, as we move forward, x is less than or equal to. Less than or equal to, or another phrase you might see that could refer to that mathematical phrase is At most. At most is another one we might see. For x is greater than or equal to a. So the English phrase for that is greater than or equal to or at least. And the last one, you can have x is equal to a. So the phrase you're looking for is equals or exactly. We know that's equality. So please keep these notes for when you go into statistics. You'll see them again in chapter 4. And the biggest hiccup here when I go through this section is when we don't understand how to take the English, the writing, and interpret it to our mathematical calculation. So you'll see this again in statistics when you go into chapter 4, and it's called binomial distribution. It's called PDF. I can't recall right now what it's called. Binomial PDF. Binomial, I can't remember. All right, so here's a very important hint. 0 may be a possibility. So don't forget 0 if it's counted or not, because it's a number we might have to consider. All right, so all of this can be generated in these examples. And we have to think about what is possible, what is not. So let's take a look at these. Translate the verbal phrase and interpret, letting and represent the values. All right, 4 pencils or less. So let's think of what this can be. 4 pencils or less. So how many pencils can we have? So a quick little hint, whenever I have an or, just like a less than or equal to or greater than or equal to, it usually means we're gonna include the number that we're stopping with. So 4 pencils or less would be, would it mean that you start with 4 and continue on to 5, 6, 7, 8? No, right, we want less than 4. So this wouldn't be the case. That's not it. So for this, you want to work with numbers like 4, 3, 2, and 1. But let's not forget, I can have 0 pencils. So this would be 4 pencils or less. This is the one that creates the most hiccups, that at most phrasing. At most, 5 people in the elevator. Well, we know that at most, we see that one often. At most applies to that number and the number is less than that. So starting with that number and the number is less than that. So at most 5 people, so 5 would be the max. And then I would want any number that's less than that would be okay, including 0. Having 0 people or 0 pencils, like our previous example, is totally a possibility. Three, the ages of children are between 18 and 23. So the biggest question is, you want to know if you're going to go to the right, do you want more? Or to the left, do you want less? And also want to consider, is this number that we're working with, am I going to include it or not? Because that's going to produce a very different answer than if I include it or not, if we're talking about probabilities in the future. So we're working with ages of, let me draw this out, between 8 and 23. So these are the numbers I want to work with. Do I want to include 18 and 23? Well, yeah, because those would be numbers that I can work with, right? Between 18 and 23. So they can be 18 and they could be 23. So for this one, our answer would be 18, 19, 20, 21, 22, up to 23. So those are numbers I want to consider. Okay, let's go on to 4. 10 tickets or more. So if you're ever confused about anything, think about something that you might consider important or maybe offensive. If you ever think about money for these situations, that really helps clear out what you're working with. Sometimes we're talking about pencils or people in an elevator, it might seem really weird. But if you rephrase it using money, or if you think about it as, I don't know, as food sometimes, it makes more sense. So 10 tickets or more. So let's say you want to buy something and you need $10 or more. So you know you need for sure need $10, but you need to have more than that, right? So this would be like 10, 11, 12. And it didn't tell us where to stop, right? So that would continue on forever. If you ever have something that's not a closed idea, you can always use an ellipse to show that it goes on forever. 5. At least 7 women in the room. And it's telling you that there's a total of 10 people in the room. So that at least, I always have to refer back to my box for the at least. And we have at least right here. So we know with at least, I have to work with that number and more than that. So that means I want 7, and I'm going to work with 7, and I want more than that. So I want 8, 9, and it's telling me that I have to stop at 10 because it's telling me that I have a total of 10 people. Okay, so we're going to work with 7, and because we want something more than that, right? For the at least, we want more than. X is greater than, more than. So we want 8, 9, and I'm stopping at 10 because it's telling me to stop at 10. Otherwise, it would continue on forever. So number 5 is something you'll see a lot in chapter 4. You're given a total number of people you'll work with or the people you surveyed, and you want to find the probability of the numbers 7, 8, and 9, 7, 8, 9, and 10 happening. So that's totally a phrasing you'll see in your stats class. Six, fewer than 7 rabbits. So if I want fewer than 7 rabbits, I will want, okay, big question, fewer than 7. So if I draw it on the number line, fewer than 7, I would shade towards the left, so I want smaller than that. So I know I want like 6, 7, 8, 9. Ooh, started counting wrong. 6, 5, 4, 3, 2, 1, 0. Right? Now I have a big question for you. Is the 7 included? Well, think about it this way. What if I had fewer than $6
It's not
in my
included?
pocket? It's not included, right? It's not
Because like
included.
money?
So
Because if, okay, yeah, sorry.
yeah, thank you so much. I was trying to see how I can think about it. But
Yeah,
but
use
yes,
money because something costs $7 and you have fewer than $7, you don't have enough.
you don't have enough. So these are the ones you might have to be very careful with and think, is that number that is written, do you include it or not? And if you're ever unsure, draw a number line. That always gets people out of binds. Draw a number line and question it, think about it. And just like you said, think about money. If you think about money, it totally gives you a different perspective. You're like, okay, I got this. Money, I can work with money. So we want numbers that are less than 7. So I know I want numbers like 0, 1, 2, 3, 4, 5, 6, and we stop there, right? There's no 7. That would be your answer for 6. Okay, So this is it for your section 4.1. Just being familiar with that phrasing and inequalities and how to translate into English will serve to be very important in your stats class when you move on. It'll save you from silly hiccups. So make sure maybe if you're working with this now on your laptop or your phone or your iPad, screenshot this. So you have this little box, this little chart we did handy. And then when you get to this in stats, you'll totally remember this phrasing because it just feels not intuitive sometimes, and that's okay. But you'll be like, okay, we did this already in pre-stats. I got this. I know how to work my way around it. So feel free to screenshot this or go back to our Zoom meeting and take a picture of it just so you have it handy when you get to statistics. All right, so we're going to move forward to some statistics. So I sent you a PowerPoint. Now, these PowerPoints are from your book. And I like to use them for the beginning chapters, maybe for the first two sections of 2.1 of chapter 2, so 2.1 and 2.2. And after that, I like to use my own little skeleton notes that we can fill in together. So let me pull up those notes.
What was the answer on number 6 from 4.1?
Number 6, let's take a look. Oh, number 6, the answer was 0, 1, 2, 3, 4, 5, and 6, not including 7.
Thank you.
No problem. All right, so let's continue with 2.1. So again, these notes will be posted on Zoom, so you can always go back and annotate them the way we're working on it together. So in this section, you'll learn about frequency distribution in the graphs, displays, central tendency, variation, position. So we're just going to be talking a bit more about graphs in detail. And as we continue with this chapter, we'll develop graphs, learn how to graph them, and learn a bit more about some basic statistical applications for graphs. All right, so this 2.1, frequency distribution and their graphs. All right, so a frequency distribution. So here we have a table, and that first little bullet point reads, the tablet that shows classes or intervals of data with the count of number of entries in each class. The frequency F of a class will number the number of data entries in the class. So here, it's giving you, it's called a type of group data. So that'd be a type of group data. Because it's not telling you exactly what it is, but I know that between 1 and 5, I have 6 numbers. It doesn't give us a number, but it can be like number of times people, what's something people can do up to 30 times, or whatever it could be, like number of earthquakes California has. So on a given day, 1 through 5, there's 5 days that have 1 through 5. And there's 4 days that have 26 to 30. I guess that's something to think about it. But that's not a good example because California has a lot more than 30 earthquakes a day, right? There's a little smaller earthquakes you can't feel. So it's a type of data that we may see. It can have it grouped. Now this frequency is a number of times it happens, right? This is our frequency, our F. Okay. Frequency distribution. Each class has a lower class limit, which is the least number that can belong to the class, and an upper class limit, which is the greatest number that can belong to a class. And we see that highlighted, right? We have a lower class limit and upper class limit. And that's just the lower end and the upper end of your classes. Now, here's something we need to develop. The class width of the distance between the upper and the lower class limits. The difference between the maximum and the minimum data is called the range. So we can develop the class width, so how big a class is, by subtracting. And we see this highlighted right here. So we look at the lower end and we subtract them from the next one to the one before it. So 6 minus 1, we have a class width of 6. I'm sorry, of 5, right? 6 minus 1 is 5. So I know this class width. I know this has a class width of 5. I know this has a, well, then to find out the next one, I'll subtract again. So 11 minus 6, we get 5. So that one also has had a class width of 5. Constructing a frequency distribution. So first, you're going to decide the number of classes. Now, let's take a look at this one. So we have how many classes? We have 1, 2, 3, 4, 5, 6. We have 6 different classes. Now, there is no limit as to how many you can make, but you don't want to make it so, you don't want to make your range, your class width so big that the information is lost within, where it doesn't even create you can't represent everything. But you don't want to make it so specific, so many different little tabs to where it doesn't really show what's going on. So you want to find a good healthy medium. Now, a general case is if you have between 5 and 20 number of classes, that's a pretty safe range to stick to. It gives you an idea to where if you don't have a lot of data, you can use 5, so you can easily represent everything. If you have a lot of data, you don't want to show too much to where it's not giving you a good representation of it. So 20 is maybe a maximum you can work with. So like it's saying, otherwise it might be too difficult to detect any patterns. Second, find the class width. Determine the range of the data, divide the range by number of classes, and round up to next convenient number. And we'll see an example of this. The class limits. You can use the minimum data entry as a lower limit for the first class. Find the remaining lower limits at the class with the lower limit of the preceding class. And find the upper limit of the first class. And remember that classes cannot overlap. And find the remaining upper class limits. So what it's basically saying is set up your lower limits first. And then just be careful to not double dip or overlap. And we'll see an example of this. And it works it out too, so you can just like write your little side notes on the side. Fourth step, make a tally mark of each data entry in the row of the appropriate class. So this is when you're given some raw data and meaning you're given the number of things, either the times a geyser explodes, number of pregnancies between a certain age and a certain county or state. Whatever you're going to be given, it's going to be a lot of numbers. So you're going to determine your classes and your class width, and then you want to keep track how many people fall within that class. So to make a tally mark, this is the best way to go about it. Make a tally mark of each entry in the row of the appropriate class, and then count. So then count the tally marks of the total frequency for each class. All right, constructing a frequency distribution. The data set lists the out-of-pocket prescription medicine expenses in dollars for 30 US adults in a recent year. Construct a frequency distribution that has 7 classes. All right, I want to have a number of 7 classes. Now, I need to do some work to be able to do this. You first want to identify, well, we have our steps, right? If you're ever unsure, you can take back your steps, and it's where the numbering starts. You want to determine the class width. So you want to determine the range. Remember, the range is where you subtract the high minus the low, and then divide it by how many classes you want. Now here, it told us that we want 7 classes, right? Want. That's really bold. We want 7 classes. That's what it's telling us. So I have to find my highest number and my lowest number and divide it by 7. So we have this here. And once I figure that out, I will be able to go from there and determine the size of each class. So my highest number is 405. My lowest number is 155. I subtract them to get 250 and I divide by 7. That 7 comes from the 7 classes that I want. Now here's everything worked out much neater. So your solution is you're going to find your highest number and your lowest number, right? Your max and your min, high minus low, and then divide it by the number of classes. So we saw that our highest number was 405 and our lowest number was 155. So you really have to take a moment. It doesn't show up right away. I know I'm not doing this a justice by trying to go through it pretty quickly, but you have to seriously stare at these numbers because when you have so much data, it's kind of hard to pinpoint which is the largest, which is the smallest. So take a moment, to like, hey, which one's smaller? I see 200s, I see 300s. Oh wait, I see a 1 something. Keep that one in mind. Oh, I see another one that's smaller. Okay. Take a moment to breathe and think through it. It could take a couple of minutes. I know for me, when I get a large set of numbers, when I'm in class, I have my cheat sheet, right? I have things set up for me so I can easily glide through it. But when I'm doing this alone, setting up my notes for a class, it does take me a minute. I have to say, hey, which one's really bigger, which one's smaller, and then double check my work. Because when you have so many numbers in front of you, it can be a bit overwhelming. So take your time. All right, so I have my highest number, which I found to be 405, and my lowest, which is 155, right? I subtract them to get 250 and use your calculator. And for sure, I need to divide that using a calculator. 250 divided by 7, I get 35.71. And the trick to this is to always round up. We always round up. So 35 point something, I want to work with 36. So this means between each class, I want 36. So we'll see this being shown. So we use 155 as a minimum. And then to go to my next one, I want to add 36. That's what we decided. And you see that circled. Okay, I'm going to erase this. Now, for the sake of us being able to focus, ignore this for now. You're only working with this. Okay, I have my lowest number. I need to make sure I include my lowest number. So that's a good starting point. If it's something off, like let's say if we had 156 as our lowest number, and you want to go by, you want to start with a 5 or a 0, you can jump down to 155. But in this case, it started 155, and that's a pretty nice number. Okay, so we found that our class width, we worked this out on our last slide. So we decided that we're gonna add 36 for each class. So 155 plus 36, use your calculator, make it easy on yourself. 155 plus 36, 191. Okay, 191 plus 36, you get 227, 227 plus 36, up until you get to a number that will include your highest number. And we said our highest number was on our last slide. Our largest number was 405. So we get to 371 plus 36, 407. You're like, okay, it's going to be included on my upper limit. So maybe you might not have to need that last one, right? So that's how you know where to stop. Once your number is included, you know to stop. Okay, once I set up my first set of numbers, now I can go ahead and look at my upper limit. Now your upper limit and your lower limit guide you. So if this is 191, then the one before it needs to be one less, 190. If this is 270, then the one before it needs to be one less, 126. If this is 263, the one before it, the upper limit before it needs to be one less. And that's what it means to be careful to not double count, not double dip, right? So it's really helpful if you first work through your lower limits, and then by then you have a default upper limit that you must work with. All right, constructing a frequency distribution. Oh, here we do this. The upper limit of the first class is 90, one less than the lower limit of the second class. And you add the class of 36 to get the upper limit of the next class, in which we did that. 4, make a tally mark of each data entry and in the row of the appropriate class. And it might seem silly that I emphasize this so much, but tallies are really nice because if you have a big set of numbers like we do, right? Everything is a number, right? If you have a tally, you can say, oh, okay, this falls under this class. I'm done with that one. Okay, this next number falls in this tally. Cross it out. Okay, this number falls in this class. Make a line. This number falls in this class. Make a line. And the reason a tally is nicer than writing 1, 2, 3, 4 is if you write 1 and then you have 2 instead of 1, you have to erase it, right? So a tally is a really nice way to keep track of it. And at the end, you can use your actual numbers, your Arabic numbers that we work with, right? So count the tally marks to find the frequency. Okay, now I can use numbers I'm used to seeing, like 4, 2, 3, 5, 6. And that's a good way to keep track of numbers. I for sure make it a point to scratch them off once I've used them. It's so easy to make a mistake and double count a number. Determining the midpoint. So midpoint of a class. The midpoint of a class is made up by your lower class limit plus your upper class limit and dividing it by 2. That makes sense, right? So for each class, right, this would be our class and it's marked as class. We add them and divide by 2. I'm sorry, yeah, we add them and divide by 2, and that gives us a midpoint. So using the width of 36, the remaining midpoints are, and you can find the remaining midpoints for each class because each one will have the same difference. The relative frequency of a class. Portion or percentage of the data that falls in a particular class. So I also like to call this, and you have this in parentheses here, it's the percent of something happening. So remember to go from decimal to percent, you move the decimal over twice, right? So a quick little example. If I have 5% and I want to write as a decimal, I move the decimal point to the right, to the left, to right. So 1, 2, that's my new decimal. So it'd be 5.05. Well, the frequency, this would be the frequency, the relative frequency. And we can always go between relative frequency and percent. So we're essentially trying to find the percent, or in this case, the relative frequency in correspondence or relating to everything else. So you're going to start by your class frequency. So the number in each tab. and then divided by your sample size. Your sample size is your total. It's the sum of everything together. That's your sample size. Now, don't be scared. You can listen to this a lot. This E. Remember that E just means system. So here it's saying to add your frequencies. So this is saying to add all frequencies. Right? E, that sigma, Greek letter sigma means to add. That F is that frequency. So I'm going to jump back to slide 15. We have that there. Our frequency is each number. So under the class of 155 to 190, we had 3 numbers that fell under that. So taking a look at that first class. And I had 3 numbers. And for each one, I had a set of numbers that fell under that range. Once I added them up, we got a frequency of 30. So that's that sigma F. Jumping back to our current slide 17. Moving forward. Determining the cumulative frequency. The cumulative frequency of a class means the sum of the frequencies for all class and all previous classes, and the cumulative frequency of the last class is equal to the sample size of n. So let's go ahead and see that. Example, find the midpoints, relative frequency, and cumulative frequency. All right, so let's take a break here to kind of break down everything we did. So we took a moment and we learned how to develop a chart using raw data. So here we were given this raw data. So it was the set of lists of out-of-pocket prescriptions for medicines, right? So let's read this again. The data set lists of out-of-pocket prescription medicine expenses in dollars for 30 US adults in a recent year. So this is how much people paid out of pocket for the medicine. So it ranged anywhere from 155 to 405 being the most out of these 30 people they surveyed. Okay, we were able to do a relative frequency chart by finding our lower limits, our upper limits, given that they want us to work with a class with a class size of 7. We wanted 7 classes. So we took our maximum minus our lower number and we divided by the number of classes. Now this number of classes 7, it can range. They can either tell you how many they want, but in a general sense, you want to keep it between 5 and 20. Depends how many data entries you have. All right, and we did all this to be able to draw this beautiful chart to give a summary. We're done with that. Okay, now we're developing new concepts. We're developing the midpoint and relative and cumulative frequencies. Remember, the relative frequency is like your percent, but in decimal form. Now we're going to do this to prepare us for later in the section or perhaps the next chapter. All right, moving forward. Using the frequency distribution in previous example, find the midpoint, relative frequency, and cumulative frequency for each class and describe any patterns. All right, so here's what we set up. Here's our graph, our chart we made. So we have the number of things falling within each class. So we saw that 3 were between 155 and 90, 2, 5, 6, 7. Now this is what's new, that midpoint. We learned that the midpoint is the lower end of the class and the upper end of the class added divided by 2. This gives us these new values, these midpoints. And it shows the work for each one. Now, this is what's new, the relative frequency. Remember, the relative frequency is like your percent. And it's always your part divided by your total. So you see how we have 3? We have 3. And the sum, the total of our numbers, well, 3 plus 2 plus 5 plus 6 plus 7, that gave us a sum of 30. So everything will be divided by 30. So my next number is 2, and I'm going to write it as 2 over 30. And next number is 5, I'll write it as 5 over 30. And we do that for every single one. And from there, we use our calculator. 3 divided by 30, you'll get a result of 0.1. 2 divided by 30, you get 0.07. So to get those answers, you use a calculator. Now, this is your relative frequency, which is your percent. And this is our answer, 0.1, 0.07, 0.17, 0.2, and 0.23. And it shows you the work, where they got that number from. Now, cumulative frequency is you're adding them up, but you're adding them up at each class. So we're going to work with 3 plus 2. We got that here. Then 2 plus 5. I'm sorry. And then 5 plus the next one. So we have 5 here. Oh, I keep erasing. So I have 5 here. Plus my next one, 5. And then I have 10 here, plus my next one, 6, like we have here. And then I have 16 plus my next one, 7. You get 23. So you keep adding the next one in. That is a cumulative frequency. So there's 2 new things we learned. Relative frequency and cumulative frequency, along with midpoint. So these are pieces that I can add to my chart. And the last slide show the work, and here it shows the answers. So I don't have to, if I want to write a summary, I can show what my midpoint is for each one without having to show the work, my relative frequency, and my cumulative frequency. Now, big important point, your relative frequency should always equal 1. And this is because it relates to the number of probabilities. So the number of probabilities always adds up to 1. And you'll see this in chapter 3 of your stats class. All right, let's go ahead and see our summary. So you have this here, right? We have our work done, and we see that there are several patterns of the data. For instance, the most common range of expenses is $299 to $234. So if you look back, the one that happened most, well, which one happened most? This one, right? Between $299 to $34. Okay. Also, about half of the expenses are less than $299. So we can see by the sum that more than half of them are less than $299. Moving forward. So now we're going to go into different types of charts that we might work with. One of them being the frequency histogram. So in other words, I always think of, though it's not correct to say, I think of it as a bar graph without spaces in between. Now, a bar graph in its own graph, but for it to be called, in quotations, an actual bar graph, we need to have spaces. A histogram does not have spaces in between. All right, so a bar graph that represents the frequency distribution, the horizontal scale, so it shows us here the horizontal scale. That could be the number of data, so that could be like our maximum and minimum of our chart. And then the vertical measure is the frequencies, how many times it happened. So the vertical scale is our frequency, how many times something happened. And the bars must touch for it to be a frequency histogram. Let's move forward, class boundaries. Because the consecutive bars of a histogram must touch, bars must begin and end at the class boundaries instead of class limits. The numbers that separate classes without forming gaps between them. So let's go ahead and take a chart that we work with. So we took the time to develop raw data, find the class according to the number of classes we wanted to work with. We found how many numbers fall under that class. We worked the midpoint. We found the relative frequency and the cumulative frequency. Let's go ahead and take that information and construct a histogram, a frequency histogram. All right, so first, find the class boundaries. Second, the distance from the upper limit and the first class to the second limit of the second class is 191 to 190. Subtract them. So half the distance is 0.5. Next tab reads, the first class lower boundary is 155 minus 0.5. So we have 154.5. And the first class upper boundary is 190 plus 0.5. So we have 90.5. So here it shows you the work. So we're working with our boundaries. How much can it be before we touch? So it's pretty much, it's 0.5 less and more. So we're going to subtract 0.5. And here we're going to add 0.5, right? So 191 minus 0.5 gives us 90.5. 226 plus 0.5, we have 26.5. So we're adding and subtracting 0.5. You can mark the horizontal scale either as midpoints or the class boundaries. Both histograms are shown below. So the reason we took the time to find our midpoints is because that can be one way to write these numbers in the bottom. You can use midpoints. And that way we can show how each one has the appropriate number that matches up, right? So we have a frequency for each one. Now, the reason we did these lower limits and subtracted the 0.5 is so we can have the other graph labeled as class boundaries. So these are your class boundaries. You see how they're on the left side, on the lower end? They're on the left because we're working with our lower ends, our lower bound of our class. And we have the same graph. So this one, that first one deals with midpoints. That second one works with labeled class boundaries. I think midpoints is something that we can easily work with, or choose a favorite and we can work from there. Now, it's important to point out that notice how we can start a broken axis. Now, think of this as a number line, right? We don't want to start with 0 and work our way up to 172.5 being our first one. That would be a lot of empty space. So you can start off to where your graph starts or your information starts. So if we're working with midpoints, my information starts with 172. I can show that I'm starting with 172. And we show that we're not starting by 0 by using a broken axis. So it's just a squiggle before you start. All right, so here it shows our class boundary histogram. So you can see that 2/3 of the adults are paying more than, so you can just make assumptions from here or read your graph and come up with conclusions. So you can see that more than 2/3 are paying more than $262.50 for out-of-pocket prescriptions. That's a technical interpretation. All right, a new graph you may work with is called a frequency polygon. So it's like our histogram that we worked with, but instead of using bars, we're going to use dots as our point. And we can connect those dots at the end. This is called a frequency polygon, a line graph that emphasizes continuous change in frequencies. So for example, constructing a frequency polygon from the chart we did. So we have our classes and we have our class boundaries. So remember, this is just we add and subtract 0.5. So here we're subtracting 0.5 from the bottom, from our lower class, and we're adding 0.5 to our upper class. So this gives us new class boundaries. And we have a frequency that we found. So a number of times that number falls into that category. All right, to construct a frequency polygon, use the same horizontal and vertical scales that were used in the histogram label with class midpoints. And we see how many numbers fall within that. So we have our class midpoints that we found, and you start labeling how many times numbers fall, like a bar graph, right? But in a bar graph, you would go maybe like from here to here, but you're not making that connection anymore. You're just seeing where each one falls. You draw a point, like when you're drawing points on a Cartesian plane. And then at the end, once you're done making all your points, you see your points line up to your midpoint. Once you're done making your points, you go ahead and you connect them to make weird angles. So the graph should begin at the end of the horizontal axis. So extend the left side to one side of the width before the left class midpoint, and extend the right side to one class width after the last class midpoint. And then we just connect. So you can use a graph for this, a calculator. But we won't go into that so much. I don't even make my stat students graph charts using calculators. We use our calculators for more extensive calculations, but not for charts. A relative frequency histogram. So a relative frequency, recall this is like a percent. So far we already graphed so let me write this down. We already graphed a histogram using midpoints. We also use class limits. Now we're going to use one using relative frequency. And we already did that. So we're going to be using decimals. So our part right here is going to be our decimal. But everything else that we did, it kind of falls the same way. So let's read those bullet points that this slide has. It has the same shape and the same horizontal scale as a corresponding frequency histogram. And the vertical scales measure the relative frequencies, not the frequency. Constructing a relative frequency histogram. All right, so it depends how you want to do it. If you want to use midpoints or class boundaries, but we're not using our frequency, we're using decimals. So notice right here, we have our decimals, so that's how often something happened. So again, I think it didn't do it justice because it didn't use, so we're in slide 35. It didn't use the whole chart. So here we have our relative frequencies, these are decimals, right? So we have 0.1, 0.7, 0.17, 0.2, 0.3, 0.13, 0.1. That's what we're going to use in our slide to draw the relative frequency. So let's go back to our current slide, 35. So this is where these numbers came from. Now they're using the lower end because we're using a the class limits for our horizontal axis, and we have our relative frequency, meaning it's our decimal point. All right, our next graph we can have is called ogive. So this is pronounced ogive. So it's a lot like a polygon graph. Let's go ahead and take a look at this ogive. A line graph that represents the cumulative frequency of each class and its upper class boundary. The upper boundaries are marked in horizontal axis. The cumulative frequencies are marked on the vertical axis. So for this one, we're going to use the big part is the cumulative frequencies. And this is where you add each class, right? You add one before it. So whatever number you have, you add them up, you're going to add the next one. You have a total number, you're going to add the next one. You have a total number, you have to add the next one. So this makes it so it's always going up, right? Our polygon graph, we only use the frequencies, so it makes these weird shapes, these weird dips. But an ogive, we're always going to add, so it's always going to keep going up. So to construct an ogive, construct a frequency distribution that includes cumulative frequencies as one of the columns. Specify the horizontal and vertical scales. The horizontal scales of the upper class boundaries and the vertical scale measures the cumulative frequencies. And plot the points that represent the upper class boundaries and the corresponding cumulative frequencies. Connect the points in order from left to right. The graph should start at a lower boundary of the first class and should end up at the upper boundary of the last class. All right, so here it shows what we're working with. We're working with upper boundaries, and we want a cumulative frequency. So remember, to find a cumulative frequency, you add these up. The first two you get 5 plus, so that's where this 5 comes from, and then 5 plus 5, which is our next one, we get 10. 10 plus 6, we get 16. 16 plus 17, we get 23. And that's how you do a cumulative frequency. And here is our ogive. We're taking our upper class limits, upper class boundary, and we're adding up our cumulative frequencies. We mark them up, and that's an ogive. All right, next is showing you how using a calculator, but it's just not something I emphasize. And we're done. Now, in summary, I'll write this here. In summary, the only one what I really want you to get from this section is how to do a chart with your classes. So your classes, your frequencies, your relative frequencies, which are your percents in decimal form. That's important. So if you can make sure you understand that, that's good. Second thing I really need for you to understand is how to do histograms. That's the one chart that's important to know how to work with. If you want to focus on one sort of histogram, maybe work with midpoints. I don't think I've ever given a quiz or a test that worked with upper class or lower class boundaries, meaning when you add and subtract the 0.5. But just knowing how to create a histogram, knowing that your bar graphs are touching, knowing that how to create them, I think that's important. Know how to draw relative histograms with relative frequencies and with frequencies. That's important too. So those are only two things that I think are important for that part. So doing your chart, getting the raw data, and being able to find your classes, right? So you take your maximum number, subtract it to a lower one, and divide by the number of classes you want. And from there, creating your charts. I think that's important. And histograms. Those are the only two things I would hope you would really make it a point to learn from that PowerPoint. everything else like ogives and polygon graphs, that really isn't something I focus on or ever test or quiz. But it's nice to know that they exist and how they're made, but don't worry too much about those. Now I know I gave you a lot of information. I'm very sorry. It's just introducing you to different graphs.
Thank you.
You're welcome. Thank you so much for being here. So today I see that we have 9 people. Thank you so much for being here. Thank you. This will be recorded, so those of us who couldn't be with us live, they can also check it out and do their homework. So your homework is all open and it's available until the end of the semester. The old one, the new homework that I'm posting up, it's there for you to try. I will add new homework for section 2.1. It won't be too much detail, so don't get scared. I know we want to throw a lot, but maybe it'll be more of those basic chart stuff like finding midpoints and finding your classes. I think that's good to practice. So I'll include a couple of questions of that on your My Math Lab for 2.1. All right. Are there any questions before we end our class for today?
How are you in quarantine?
How am I in quarantine? I'm getting a little stir crazy, but I don't go out at all. I made a point to kind of prepare and stock up like back in February because my sisters were very worried, and also my family was really worried about it. So I try to stock up, and I'm just home all day.
Oh,
How are you guys doing?
I can still hear like scratches inside my wall here because I couldn't sleep last night, and it's like the mice are trying to like bite in to make the hole here, and I feel like I just want to move away.
Oh, you want to go away? You should go order on Amazon some rat traps or something.
Probably poison.
Probably poison, but then they're gonna die in your walls.
Yeah.
Yeah.
My dad told me they're trying to like get into my room, and I feel like, oh no.
Oh, from the outside?
Yeah, like they're probably like gonna be like somewhere around here.
Uh-huh.
And I have a feeling that I'll probably go sleep in the other room instead.
No, I think it should be fine, but I've been seeing on the news that animals are coming out more because there's no humans out, right? That there's like deer in oceans or by beaches and stuff like that.
Yeah.
I heard about that on the news.
Even my dog is still like, she wants to remain sleeping in my room instead of like sleeping downstairs all alone because my Yorkie passed away when he got, like he was so old right now, like last year.
Oh, so sad. That's so sad. I'm sorry. But at least you're home.
That's her.
Oh, it's so cute. We should all share our pets. I have a secretary. So this is my secretary.
I like cats.
She's always with me in my little workspace.
Yeah.
All
What's
right.
your cat's name?
Lola.
This is Moshu. Named her from.
Oh, that's cute. Mulan.
Yeah.
Oh, that's so cute. All right, then. Well, I hope you're all doing well. I'm sure you guys are very overwhelmed with all the information I gave you with the statistics and all the work we're doing. So I'll go ahead and end our session. But thank you so much for sharing with us, Abby. If you want to share with us, tell us how you're doing in quarantine, feel free to do so. Are any of you working right now?
Not really. I can't go out.
Okay, that's good. So if you're not working, that's good. Make sure you stay indoors.
Yeah.
All right, well, I'll go ahead and end the session. I'll post it online as soon as it's available. Hope you're all doing okay. Stay home. Don't go outside. The news said don't go outside this whole week, so stay indoors if you can. Bye, guys.
Bye.
Have a
Thank
nice
you.
day.
Bye.
See you Thursday. Bye-bye.
Yeah.